Welcome to our discussion on the U.S. customary units and, more importantly, unit conversion. So units is just a fancy way of talking about what kinds of numbers we have, often called units of measure, and then it's just shortened to units. So things like feet, inches, gallons, pounds, and then of course in the metric system, all of their metric measurements, centimeters, kilograms, so on and so forth. In this one, we're just going to concentrate on the U.S. customary system of units, the worst system out there. Metric is definitely a million times better, but for some strange reason, we have stuck our heels in the sand and refused to switch from this one. So it entails a lot of memorization of terribly confusing conversions, like why 12 inches in a foot, why 3 feet in a yard, why 16 and a half feet in a rod, and why 5,280 feet in a mile. These are all just silly, silly numbers. Same thing when you start getting into liquid capacities, right? 3 teaspoons in a tablespoon, 2 tablespoons in an ounce, and so on and so on and so forth. At least a lot of these are powers of 2, but they still are silly. So my advice is, if you have to deal with these at all, definitely just have yourself a little cheat sheet that gives you these conversions. So for instance, if you're given the following simple thing of converting 3 yards to feet, we know that there's 3 feet per yard, so it's 3 times 3 or 9 feet. Well, what happens if it gets a little bit more complex than just something as simple as going from 3 yards to feet? Well, we can use what some people call the unity fraction method, which I think is just a lot of fancy words for the conversion line method. Now, the unity fraction method is where you can take every single relationship between two things, right? Any conversion relationship, and always rewrite it in terms of one of the measurements being a 1. So for instance, all of these are already unity measurements on the left-hand side, where 1 cup equals 8 fluid ounces and so on and so forth. But what if you needed to go from ounces to cups? Well, then you would have to divide both sides by 8 and say 1 fluid ounce equals 1/8 of a cup. And that's what the unity fraction method is. It's basically whatever you want to convert from, you got to get a conversion that is in a 1 to something rather than a 3 to something. So for instance, we know that the conversion is 1 yard to 3 feet. And so we can form fractions of 1 yard over 3 feet to get the yard to feet as being 1/3, and 3 feet to 1 yard being the 3 to 1. And these are called unity fractions because technically these fractions still equal 1, i.e. unities not meaning together, unities meaning a single unit, right? That they're equal to 1. And then when you have this idea of a unity fraction, then you can use the conversion line technique to convert from anything to anything, including compound measurements, like feet per inches to miles per hour. You can still use the conversion line and these unity fractions. So let's look at an example. You want to convert the distance 4 yards to foot. Well, we know that you've got basically 4 times 1 yard, right? And we know that 1 yard is equal to 3 feet. So here's our unity our unity fraction, of 3 feet over a yard. And when you multiply a yard times this, the yards cancel, right? And you just get feet left on top. So you get 4 times 3, you get 12 feet. Well, we already knew that, right? But this is just highlighting how it works. Now, in order to help you understand how this works, you have to remember that any number is equal to itself over 1. So we can take things like 4 yards and write it as 4 yards over 1. And then all the fractions line up, and we get this common line that goes all the way through them, and that's what I end up calling the conversion line. So to convert from 44 ounces to pounds, we have to remember that a pound is 16 ounces. You're right. We can write it in either way. We want to convert ounces into pounds, so we need to get rid of ounces and bring in pounds. That's why we need pounds on top and ounces on the bottom, because remember, this is going to be ounces over 1. So we're going to ounces times pounds divided by ounces. The ounces cancel out, and you basically just get 44 pounds over 16. Take 44 divided by 16. Force reduce it. Do whatever you got to do. And that's your answer. Now, because 44 divided by 16 doesn't work evenly, it doesn't come out to a pretty whole number, you can write your answer in different ways. You can write it as a mixed number and say that the answer is 2 3/4 pounds, or 2.75 pounds is a decimal, or you could rewrite it in terms of pounds and ounces. So it's 2 full pounds, and then it's 3/4 of a pound. So you would take 0.75 times the 16 ounces that are in a pound, and you would get those 12 ounces kind of as a remainder. So basically, this is kind of talking about it's 2 with a remainder of 12, which is what would happen if you just did long division with 44 and 16, right? So you wouldn't have to convert back and forth, so to speak. Like, you wouldn't have to take the 0.75 and multiply it by 16. If you just did 44, right, divided by 16, go 2 times 16 is 32, subtract this, get a remainder of 12, and there you go. There's my 2 remainder of 12. And since we know this was, 44 ounces, we have a remainder of 12 ounces, right? So here's my 2 pounds with my remainder of 12 ounces. So if you can do some long division, that'll help you as well. But if you're doing everything in your calculator, you're going to get a decimal, and then you have to realize to take that decimal and multiply it by the converting factor to get back to a whole number of things. All right, how about 1 rod equaling 16.5 feet, 1 yard equaling 3 feet. So now we can convert 11 yards to rods. So the first thing we do is we go from yards to feet, right? So that's why we've got yards on the bottom. So the yards will cancel. We'll be left with 33 feet. Then we multiply that by rods over feet. So we can cancel out the feet. And we're going to have 33 feet right on the top, 16.5 on the bottom. Do the math, and it becomes 2. Luckily, this one came out to a whole number, and our answer is just 2. And you can see that as we start looking at these fractions, if we just kind of draw the line all the way through, that's why I call it a conversion line. So here's a great visual example of that. The average American consumes about 44.7 gallons of soft drinks per year. How many 12 fluid ounce cans would this be? Well, we have to convert gallons down to ounces. Now, you might know that conversion, but you might not, and you might only have, a little kind of cheat sheet of things that would go from gallons to quarts, quarts to pints, and pints to ounces. So you have to kind of do each one as an individual step. Now, again, I would put this first one, I would write this first one as this over 1, so that you would just have this line going all the way through, right? Move that up and just match everything. And so you've got this nice little conversion line. But in any case, you can see how it's very clear that gallons cancel out gallons, and we have 4 quarts in a gallon, 2 pints in a quart, so the quarts cancel. And then we know there's 16 fluid ounces in a pint. The pints cancel. And when we're left, all we have left on top are fluid ounces, and all we have on the bottom are a bunch of 1s. So it's 447 times 4 times 2 times 16, or 5,721.6 fluid ounces. Now that's how many fluid ounces we have. Now we need to figure out how many 12-ounce cans that would be. So the last step is to take that answer and say 1 can over 12 fluid ounces. By the way, we could have just stuck this on the end of our whole thing and done it all at once. But in any case, we're taking that number, we're dividing it by 12, we're getting 476.8, which is basically the same, we'd round up and say roughly 477 12-ounce cans of soft drinks, which is more than 1 a day. So if that statistic is correct, of 44.7 gallons, which I sure hope it is not, that's more than 1 a day, which is a lot. Okay, another example, The circumference of each tire on a truck is approximately 98 inches, which means that the truck travels 98 inches with each revolution of the tire. How many miles will the truck travel if the wheels make 8,500 revolutions? Well, we go from revolutions to inches because they told us that it travels 98 inches in one revolution. So now we have something in inches. Now all we have to do is convert inches to miles. So we bring in some more conversions, right? And we go from inches to feet, with the inches canceling. Then we go feet to miles. Everything cancels out. We have nothing but miles left on top. We got the first number on top, the rest are on the bottom, so we're dividing by both of those. 13.147, or roughly 13 miles. Okay, compound units work the same way with the conversion line. That's the beauty of this tool, is it works the same for everything. So compound units are simply just something per something, right? Miles per hour, gallons per minute, right? Usually time is a lot of oftentimes, no pun intended, is going to be the kind of the bottom of your fraction. But there are other things. Okay, so here's an example. Car travels 75 miles at a constant rate of 1.5 hours. It's moving at a speed of, 75 miles per, right? Per always means divided by, per 1.5 hours. We get 75 divided by 1.5 is 50, and miles over hour becomes miles per hour, and of course we would just write it as mph. How about area? We could take area and we could break it up into its two dimensions. So if we have something that is 1 square foot and we want to figure out what it is in inches, you can just convert each measurement, right, and go 1 foot's 12 inches, the other foot's 12 inches, and then do the math, 12 times 12. Or you can think of it as using the conversion line. You just have to convert things twice. So let's say we wanted to figure out what 4 square feet were in inches, right? So now you've got 4 feet by 4 feet. Well, of course, you could go 48 times 48 because you know how many inches are in a foot and do it there. But what if this was like, 3.2 and 6.7? You don't want to convert those to inches first. That's a big pain in the butt. So instead, you can think of it this way. So this is, right, 4 times 4. We've got 16 feet squared, and we want to convert it into inches. Well, we know 1 foot is 12 inches, and that would cancel one of the feet, but it's feet squared, so we got to do it all over again. 12 inches is also 1 foot. These are my unity, right, fractions. And so with those 2 feet, it cancels out both of them. And now my answer is going to be in square inches. So I go 16 times 12 times 12. I get a big old number, and it's going to be in square inches. So that's the idea of the conversion line, is you can do it really easily even when the numbers are ugly, right? So like I said, you could have made it 48 times 48, but what happens when you have decimals? It makes it a lot easier, like this example, right, to do the conversion line. We know that we can do, you can memorize that a square foot is the same thing as 144 inches, or you can always just fall back on, because I have a terrible memory, I don't want to memorize these things, of doing 12 inches is 1 foot, and another 12 inches is the second foot, because foot times foot is foot squared, and those will cancel that out, and 12 times 12 is 144. That's where it's coming from. So I think it's easier to do that than to have like a whole nother set of memorizations, right, or things to memorize, that a square foot is this many inches, a square yard is this many inches, and so on and so forth. No, you can do all of these, except for acre, because we didn't talk about acre before, but you can do the foot to inches, the yard to inches, the rod to yards, all of these squared things you can do by just using the conversion line and doing each unity fraction twice. Same thing as going from, square miles to square yards or any of those. The only one we didn't talk about before was acres, because before they were all linear measurements. An acre is not a linear measurement. An acre is a measurement of area, right? So it's really the only one we'd have to bring into the mix. Just knowing that an acre is equal to this many square feet is really kind of the more common one. And then once you go from there, you can convert square feet to square yards very easily. And you can also convert to square rods very easily by just knowing the conversions between feet and rods, right? Because there's an easy feet to yards, 3, and then feet to rods, I think was 16 and a half, if I remember off the top of my head. So all you have to know is that the acre is 43,560 square feet, and then you can go from there. Okay, how about an example? Well, in this example, we're going to use basically the things from this page. But remember, we can always just do these things twice, right? We could go, well, in acres, we have to know something about acres and square miles because there's no other conversion. Okay, volume is just these measurements done 3 times, right? So foot times foot times foot gives you a cubic foot. Of course, 12 times 12 times 12 gives you this big, huge number in cubic inches. What do you want to bet they're going to give you a slide with everything that's cubed, right? All the volumes, sure. Or again, just use the unit conversion and just do things 3 times. I think it's a lot easier than trying to memorize or have 7 different pages of notes telling you that a cubic foot is equal to this many cubic inches. I would just go 12 over 1, 12 over 1, 12 over 1. That gives me a cubic foot. I know I go 12 times 12 times 12 times 0.25, and I get the exact same answer. So I think, the cubic foot to inches, the cubic yard to feet, those are all wasteful. You don't need those because you can just figure them out by the standard regular conversions and doing them 3 times. These, however, you have to have something, at least one of them, especially gallon and ounce and pint. Those 3, right? We have relationships between gallons, ounces, and pints. We know how many ounces are in a pint. We know how many ounces are in a gallon. We know how many pints are in a gallon, and so on and so forth. So we really don't need all 3 of these conversions. We just need one of them. And I would go with this one because it's the only one that doesn't have a decimals, right? Just have 1 gallon equals 231 cubic inches. And now you can convert fluid ounces to cubic inches, pints to cubic inches by just going through gallons, right? So for instance, if I had 1 fluid ounce, right? And I want to go to cubic inches. Well, I know 1 cubic ounce, right? We can have ounces down here and we can bring in gallons. Now, do you remember how many ounces are in a gallon? I don't have it memorized either, right? So we got to go back up to where we had that stuff and remind ourselves that 1 gallon has 128 fluid ounces. Okay, so 1 gallon is 128 fluid ounces. So now we've taken our ounces, we've gone to gallons, and now if we just have this one on our, quote unquote cheat sheet, then we can have 1 gallon is 231 cubic inches. Gallons cancel, right? Ounces cancel. And all we got to do is 231 divided by 128 in our calculator, and that will give us how many fluid ounces, i.e. it'll come out to this, or sorry, how many cubic inches, because our answer will be in cubic inches, how many cubic inches we have in a fluid ounce. Now, if you want to put all of them on a list, that's fine. But what I'm trying to point out to you is that, math is not about memorizing 5,000 things. It's about having a small list of things you have to memorize, and then everything else you can derive from just some simple logic and some simple techniques. Now, you may have noticed that the volume units of the gallon, the fluid ounce, and the pint were all defined earlier as liquid capacity units. Think of liquid capacity as the amount of liquid that you can have in a container. And these units can also be defined in terms of cubic units, which is the amount of 3-dimensional space that's taken up by each amount. So a gallon contains 128 fluid ounces. That's the liquid capacity. But that amount of liquid also takes up a volume, right? Kind of like a capacity of air that would be equivalent to 231 cubic inches. So it's just 2 different ways of describing the same space. It's just, are you describing it by how much fluid is in that space, Or are you describing it by how much square area is taken up, or sorry, cubic area is taken up by that space? Okay, another example, to convert 10,500 cubic inches to bushels, we can set up the following. If we know how many cubic inches are in a bushel. So I hadn't touched on those other ones in the previous. We talked about gallons, ounces, and pints, all kind of coming from the same thing, and we could just use one of them. But just like acre, bushel is a whole new measurement that's not related to anything else that we have to put in our list. And we can either do bushel to cubic inches, or you could have done bushel to something else if you wanted to that didn't have a decimal. But in any case, bushel is a new one that we have to learn. So here's that conversion, about 4.88 bushels. Barley has a density of 38.44 pounds per cubic foot. 1 bushel of barley weighs 48 pounds. How many bushels of barley are contained in 3.25 cubic yards? Well, first thing you got to do is figure out the number of bushels in a cubic yard. So we can do that through a cubic foot and then kind of go from there. So here's our cubic foot and pounds. They tell us there's 384 pounds per cubic foot. You can see per turns into a fraction. Now we've got how many pounds are in a bushel, right? 1 bushel weighs 48 pounds. So there's 1 bushel equals 48 pounds. There's another unity fraction. And the pounds will cancel. And now we're in bushels per cubic feet. Then the last thing we know is that we can go from cubic feet to cubic yards, either by having this memorized, or we would do the 3 feet over 1 yard and do that 3 times, so that we would have cubic feet on top and cubic yards on the bottom. Then the cubic feet would cancel with the cubic feet, and we would have cubic yards down below. So whether you want to do 3 over 1 times 3 over 1 times 3 over 1, or if you want to memorize all these extra things, it's up to you. But in any case, like all fractions, multiply across the top, multiply across the bottom, divide that, right? So take the top thing and divide by all the bottom things. After we've canceled everything out, which you can see we now have bushel over cubic yards, we get 21.6. Now that we know that, and if we want to know how many bushels are contained in this many cubic yards, well, then we're multiplying by cubic yards over 1, so the cubic yards will cancel, and we'll get our answer in bushels, 70.2, or roughly 70 bushels. Okay, lumber measurement. Oftentimes when we talk about the volume of a piece of wood, it's measured in what are called board feet. And 1 board foot, there's various ways to write it, BF, BDF, FBM, and so on and so forth, of lumber, is a piece having an area of 1 square foot and a thickness of 1 inch. It can be less depending on certain materials. But basically think of it as a square foot piece of wood that's 1 inch thick. That's a board foot. So the number of board feet equals thickness in inches times width times length. In this case, thickness in inches being 1, so you get 1 times width times length. And that, using that simple formula, we can find how many board feet we have in anything. A 2x4 used in framing a house actually measures 1.5 inches by 3.5 inches, but we would use the normal 2x4 inches when we're calculating board feet. So a 12-foot length of framing lumber that's 2 inches thick by 4 inches wide, i.e. a 12-foot length of 2x4, would have a volume of 2 inches times 4 over 12. That's our 4 inches over 12 to make it in feet, times 12 feet, and we get 8 over 12 times 12 equals 8. We get 8 board feet. Does that mean anything? No, not for most applications. But oftentimes when you're ordering large orders of wood, you'll order it in board feet. I need this many board feet of blank. I need this many board feet of this. Another example, put the floor down on a small building requires 245 boards. Each of them is 1.5 inches by 12 inches by 12 inches. Determine how many board feet should be ordered. We find the volume of the board, which is 2 inches. Remember, it's 1.5 inches thick, but it's still considered a 2x, right? So it's 2 inches by 12 feet, because it's, that's what it is. It's 12 inches, which is really just 1 foot. So we could have said 1 foot by 12 feet. And then times 12 feet. So basically you get 24 board feet. And then for 245 boards, you do 245 times the 24, and you get that many board feet of lumber. So you could tell them that's how many board feet I'm ordering, and they can figure out how many boards it is. But like I said, it's not used that much. Speed is another very common compound unit of measure, right? 60 miles per hour. So we need to, of course, remind ourselves of seconds, minutes, and days and all that fun stuff. Because if we want to convert 55 miles per hour to feet per second, we got to use the 5,280 feet in a mile to cancel out the miles. And then 1 hour is 3,600 seconds. I would have done 1 hour is 60 minutes. 1 minute is 60 seconds, right? Instead of having this memorized. And then those two things would cancel out to give us the exact same thing. And we can see that 55 miles per hour is roughly 81 feet per second. All right, convert inches per second to feet per minute. It's no difference, right? You set up every unity fraction so that whatever you're trying to cancel out gets canceled out, and you leave behind what you want, right? So the seconds cancel, and when you're done, you have feet per minute. Here's another one. We've got how many miles per lifespan. We've got miles per gallon, all sorts of stuff. So the car gets 40 miles per gallon. And then the four-cylinder non-hybrid has an average fuel economy of 27 miles per gallon, but it costs $3,720 less. If gas costs an average of $2.40 per gallon, boy, this is an old slide, I bet, because nowadays it's a lot more. We can calculate the amount of money the hybrid would save over a 160,000 mile lifespan. 160,000 miles equals 1 lifespan. But we also we get 1 gallon over 40 miles, right? 40 miles per gallon. So that cancels our miles. And then we have $2.40 per gallon. So the gallons cancel. And if you multiply across the top, you only have money. If you multiply across the bottom, all you have is 40 lifespans, right? So it's going to cost us $9,600 per lifespan, basically in a lifespan. So over the lifespan of the car. Then we redo everything, but with the other car's stats of 27 miles per gallon and 240 is still the same price. And we get $14,222. So the difference between the two, right, the hybrid would cost us $4,622 in gas. However, remember, they told us that the hybrid costs more. So in essence, it really only saves us $900 over that 160,000 mile lifespan. So it's just one way of determining which one's the better economic choice. So here is a table with basically all the things you need to know. Some of them, like I said, are kind of repetition that you don't necessarily have to have. You can just use others to get to them. But if you had all of these in one place, like I have it here for you, it's very handy to tackle any of these types of questions. And that's all I've got for you.